So, hi students. Today we can proceed with the next topic of your gate, that is the decision tree. So, what basically in your decision tree and what basically you need to be understand in this complete concept. I hope previously we have completed over multiple topics on the supervised learning of this particular series. We have finished all these topics, and at last we are on the supervised or the support vector machine. Okay, after this, from this particular unit, we can proceed on the decision trees and what are the significance of decision tree and how you can, what are the core concept of the decision tree we can see in this particular session. Okay. Now, these are some reference book, as I have already told you in the previous video also, that you can proceed with these books. Mainly, you can go with the NPTEL contents and the BITS planning contents they have, and the MIT Press contents of the machine learning to understand the core concept and the basic as well as the hard and the more advanced version of the machine learning concepts by these particular sessions. Now, what are the decision tree? First, you need to be understand that. Some basic thing you have to understand initially. Let's take a real-time example that you need to be purchase certain product on the Amazon or a Flipkart. So you need to be make a decision there that first, if you like that particular, for example, if you want to purchase a product, in that case, there may be the two things in you, that whether that product is useful for you or not useful for you. It is a household product, it is for the kitchen product, and like this a decision will be become, a complete tree will be become. So you can found that since we have used two major decisions you need to be take, that's why it is known as a binary tree also. Just like that, we need to be make a decision trees in your programming as well as in your supervised machine learning. In most of the problems, you make a decisions and you make a decision trees for that, and the combination of these decision trees and advanced algo will be referred, you will found in the random forest. But what basically a decision tree and what is significant? So it is nothing but we can say that it is a supervised learning algo. What it is used for the classification. For example, a complete data set have a multiple data points, multiple classes you have. So you to classify these classes, you can use the decision tree. So for that decision tree classifier is most commonly used. Then the regression, for decision tree regressor is mainly used. So two major things where decision tree algos is most commonly used are the classification, that is the decision tree classifier will be there, and the regression, just like the decision tree regressions will be there. If the model decisions as a tree structure, okay, it models decisions in a tree structure. Just like that, you have seen that whether you need to be purchase a particular product. If yes, then proceed further. If not, then it will be the and. Not useful, then you can just go with that. Okay, even just taking a normal example, that for whom you are producing, you can just take the product. For someone else, for yes, no, for itself, you can proceed with this. Okay, and that whether the product is reliable or not reliable, warranty constraint. So you are just making the tree in this case. So just like that, this particular problem can be resolved in the tree format. That's why this is known as a decision tree. We have a root node in that. You must have to keep in the mind that in the decision tree we'll have a root node. So the first and the foremost thing part in your decision tree is your root node. Okay. Then we have internal nodes. These are the remaining other nodes are your internal nodes, which are known as a feature test. And the root node is the entire data set. In the root node, you put your entire data set. In the internal nodes, you put some feature tests there. Then we have a leaf nodes. These are nothing but the class labels or the numeric values you have. So in the upcoming slides also, you can find that how these are three things will be classified, in which you must have to be keep in the mind in the decision tree. We have the three major things. First one is the root node. What are the root nodes? They are entire data set, the complete data set you have put on the root node. Then internal nodes, they are nothing but the feature test. Leaf nodes, if I'm whenever I'm using the leaf node, that it means that they are nothing but the class labels, they are the numerical values. I hope the things are clear till now. This is a very simple algo, and but it is an important classifier. Okay, decision tree classifier are used in most of the machine learning algos as well as in the supervised machine learning techniques. So you must have the basic understanding of that as well. So this is the classification where you found the decision tree classifier, in which three major things you need to be captured from here. One is the simple root node, second is the internal node, and third is a leaf node. So whenever I use the term leaf node, that simply means I'm saying that it is a class label or a numeric value. I'm dealing with that. Okay. Moving further, what are the key terminologies in this particular segment, in which number one is a splitting. Okay, so dividing a node based on its feature is known as a splitting. So most of the time you have seen in the multiple things and multiple terminologies when you can study the notes of this particular session, you found the splitting term is used. So when we can use the splitting term, this is nothing but a simple analogy is that you just divide the node into on based on the feature. Then features and the attribute, I'm just classify each and everything so that from 0 to topmost level, whichever you want, you can easily cover up that things. You can understand each and every segment. For example, if somewhere it is term splitting comes, that means you can divide the node into based on the feature. Now feature thing will be there. So what is a feature? It is nothing but the input variable. Whenever I can say feature or an attribute, that means it is an input variable. Then a term is most prominently used is the threshold, value used to split continuous features. Okay, so threshold is nothing but whenever you need to be explode, okay, you need to be split the things, then you can use the term threshold. A particular threshold, for example, anything which is less than 50 will have certain threshold. So I set a threshold of 50. So less than 50 comes in this particular class, more than 50 comes into this class. So this is a type of threshold. Then the depth, length of the longest path from the root to the leaf node. And then this is simply the depth from root node to the leaf node. How much depth it is, that is in general term known as a depth in the decision tree. Then impurity, that is measures of heterogeneity in a particular node, is known as the impurity. Now, I have just mentioned you this particular diagram through which you can easily understand that what is a root node and what is the splitting, what is a subtree, and what is a branches we have. So you can find that A is the parent node of B and C. Okay, here this sub tree we have, or the branches we have. Initial and the first node is known as the root node. Always keep in the mind, this is your root node. Okay, this is the root node. Okay, here the entire data set will be present. Okay, so this is your root node. After that, we have splitting this. We have done the splitting where two root nodes are there. First one is a decision node, and second one is your second decision node. So decision nodes then further divided into the terminal node and the decision node. Okay, this decision node have further terminal node. Terminal node when no further node will be present there. Okay, no further node will be present there. Then we can say that it is the terminal node. Okay, no further thing will be present. You have found that no further movement will be there. So this is your terminal node. Decision node, why it is said decision node? Because after again you need to take the decision. So since at last these things are we do not take the any decision at last, so these become the terminal nodes. So key things I hope you are able to understand, that root node, decision node, terminal node. Terminal nodes are those nodes where decision holds. Decision halts. Okay, and these are the decision node. Root nodes have again further classification as the decision node, and this complete, these two are the similar subtrees. Okay, the tree have a subset which are the subtrees, okay, or the branches we have. So this is a subtree in which we can say that this A is the parent node for B and C. A is nothing but the parent node of A and B and C. Okay, I hope this diagram will be, you are can able to understand the basic things, that what is a splitting, what is a root node, what is a decision node, what is a terminal node. So this is a basic flow chart through which you can easily understand. For each and every problem which we have given to you, you can use the decision algorithm in that. Then you can make this tree, decision tree there. That's why it is known as a decision tree algo. Okay. Types of decision trees, the important thing. So first type depends on the classification tree, and second we can say that the regression tree. So classification tree output is discrete class labels we have. For the classification tree, what are the outputs? Have to keep in the mind that we have the discrete class. Keep that in mind, students. These are very important concepts, even with respect to your gate point of view, not only in the machine learning or the any other DA examination, but also this algo is useful in multiple other domain examinations, just like the CSC examination and the ECE examination. Also decision tree will be there, because DSA will always remains same in each and every part. Okay, so common algo in this ID3 information gain. In some separate video, I can explain each and every algo in depth. C4.5, that is the gain ratio. CART, that is a gain index. All these things, a brief introduction of gain index, gain ratio, information gain, we have already discussed in this particular slide. But for in-depth, we can make a short videos on that. But right now, our main focus is on the decision tree. So we can focus on the decision tree. We can explain these things in a brief note in the upcoming slides. Don't worry about that. So we have the common algos, but for the key point of view, you must have to remember that our common algos are ID3, C4.5, and the CART. These are known as information gain is important here. Gain ratio is important, gain index. What are these things? In the upcoming slides, you all can understand in depth of all these things. Now the regression tree, the second type of trees are the regression tree. See, students, that we have started a supervised machine learning with the two major terms in the initial session also, that we have the classification, we have the regression. Only two things are there. So we need to be understand that how classifications basically proceeded and how regression will be proceeded. Even right now in the decision tree also, two major things are most important. One is a classification, second one is a regression. So classification, where output is discrete, regression, output is continuous. Okay, output is continuous value. How these two are classified? In the classification is discrete, regression trees where output is continuous. Splitting based on the variance reduction and the MSE, mean squared error. I hope we have already discussed in the previous videos already what is the variance and what is the MSE. Here type of a decision tree, that is the classification tree and the regression tree. So you found that the short data into categories, that is just like an example we have taken, span mails, inbox, churn, no churns will be there. Similarly, regression tree, predict a continuous number. For example, $430K is there. So it will be greater than 475, then 450, 450 or the 551. So a continuous numbers will be there. So that's why we have the two major classification. One is the, see that classification tree, decision tree are the classification tree. And second type, type 2, this is the type 1, type 2 is the regression tree. Regression tree. Okay, I hope till now the things are clear to everyone. That's great. Now, impurity measures, one of the most important concept with respect to your gate part. So you can proceed with this impurity measures first. So what are the impurity measures and how you can measure the impurity, that can be important. Now, first thing is the entropy. Now understand, I hope everyone, you all are the BTech students. So you have done complete your chemistry and the physics in 11th and 12th. There a term comes known as the entropy. So I hope if you remember that entropy is nothing but the randomness, is the measure of randomness. What amount of randomness will be present in the gaseous molecules or the liquid molecules there. So just like that, the same thing, the entropy comes here. Okay, entropy, if you know the basic concepts of entropy in your early late 11th or 12th, then definitely you are here easily understand the meaning of entropy with respect to the decision trees and with respect to the data. So entropy is a term comes from the physics. Okay, means measure of disorder. What is the entropy? Is the randomness, or it is nothing but the measure of disorder. Try to understand, these are the very important things. Okay, every single point which I am telling here is important. Okay, keep in the mind. That's why mind map will become in your mind, that how the things will be related. Entropy, you can relate entropy from the randomness. Randomness yani measure of disorder, how much disorder will be there. So in the context of decision tree, entropy is a measure of disorder or impurity in the nodes. How much disorder and the impurities are present in your node, that can be take care. Thus, a node with the more variable composition, such as to pass or to fail, would be considered to have higher entropy than a node which has only one pass or one fail. If you have the two pass or the two fail, that means it has the higher entropy. If you have only one pass or the one fail, that means that tree has a lower entropy. So the maximum level of entropy or the disorder given by 1 and the minimum entropy is given by the value 0. So you can say that entropy value lies between 0 and 1. ये चीज आपको समझनी पड़ेगी बच्चों की, एंट्रोपी जो है वो 0 से 1 के बीच में लाई करती है. क्या करती है? डिसऑर्डर को बताती है आपके, व्हाट इज अ डिसऑर्डर इन योर पर्टिकुलर segment or a particular we can say the decision trees. And what are the disorders? Disorder in the impurities in the nodes you have. Okay, so here is a basic formula for that. HS, I have used the same significance or the same notations which you have already done in the previous 11th or 12th. That is H. S is the entropy, which is nothing but entropy is always be negative. Negative of I equals to 1 to C, P of I log 2 of Pi, where Pi is nothing but the probability of class I, if you are using the class I. So ith class, I1 to the C class, how many classes are there? If 3 are there, so C will become 3. If 5 classes are there, C will become the 5. So entropy is nothing but sum of all I equals to the 1 to 3. Pi log 2 of Pi. You need to be remember this formula. Pi, where P is nothing but the probability of occurrence of class 1. Range from 0, if you get the entropy 0, that means randomness is 0. Randomness is 0, that means and decision tree is a pure, that is pure. If you get to I2 log 2C, it will be vary. So log's value will mainly from 0 to 1. That's why we can understand that highest value for this is the 1. I hope the basic concept of entropy is clear. So first indicator or the first factor is easily understood. That is the entropy in the decision tree. I hope we have started with the decision tree. We understand the key concept or the key terminologies in the decision tree. After that, we comes on the basic or the variations we have in over decision trees, in which first we have discussed about the entropy. We have on the impurity measurements. What are the impurity measurement? First impurity measurement is your entropy, and the formula is just simply sum of all minus of sum of all I equals, don't forget this minus, keep that in mind. In the hurry in बहुत जल्दबाजी में आप गेट के अंदर ये भूल जाते हो नेगेटिव साइन लगाना, और उसके अकॉर्डिंग उसमें ऑप्शंस भी इसी तरीके से दिए होते हैं कि आप कंफ्यूज हो जाएं. ओके, आप माइनस की जगह जल्दबाजी में कभी प्लस वाला ऑप्शन देखा तो प्लस 0.4 आ रहा होगा, नीचे माइनस 0.4 आप इग्नोर कर देंगे और प्लस 0.4 पे टिक लगा के आएंगे. सो ये नेगेटिव को डू नॉट फॉरगेट, बिकॉज इट इज अ measurement of disorder. Just keep in the mind with the impurity that it is a disorder. Disorder is a negative term. That's why negative you will get there. Now, information gain, in short, it is the ID3. Just nothing but information gain is just simply S comma A, where just simply entropy you can minus with S of V divided by S of A, multiply by s of h of change in entropy with h of SV. So closed features with maximum information gain we have, and here we have considered the bias. Bias is just simply favor the features with more values. This is known as a information gain. So right now I'm not going in depth of this. In the upcoming slides or the next video, I definitely discuss this information gain and the gain index in more detail. Right now, the major important thing is just you need to be focused on this particular part. Okay, just remember this complete formula. Okay, so moving further, you need to be understand this complete formula, that is I, G, S, comma A we have, that S is nothing but the current data set, A is the feature or the attribute you are considering for splitting. So S is nothing but your current data set, A is the feature. Okay, A is nothing but a feature or an attribute you have, okay, where you are considering for the splitting. What is HS? HS is nothing but entropy of a data set before splitting. HS is nothing but entropy of data set before splitting. How impure or uncertain it is. Okay, we have already discussed in the previous slide that HS is nothing but it is a entropy. Then we have just simply V belongs to A, that is each possible value of a feature A. SV is nothing but subset of S, just S, which is your current data set, where feature A has a value V. You have to keep in the mind it is nothing but SV is the subset of S, where where the feature A has a value V. I am just writing here the things. We have SV. What it is? It is subset of S. We have subset of S where feature A has value V. Okay, then SV divided by SA is nothing but the proportion of a sample in that particular subset, and HSV is the entropy after the split of that particular data set or the subset we have. So information gain, what it basically measure? It's measure how much uncertainty is reduced when we split a feature A. Okay, so how much information gain is what it is? How much we can just say that it's just simply uncertainty is reduced when a feature is splitted into a. Okay, split on a feature A. How much? You can just write it here. Information gain. I hope you have written this. How much uncertainty? How much uncertainty is reduced? I've just can I write it down? Uncertainty. I hope you have written this. Uncertainty is reduced when we split a feature A. Okay, so A is the feature, and as we have just simply current data set. In this current data set, SV is just simply the value or the subset where feature A has the value V you have written and the entropy of that particular feature. This is the information gain. So its name itself, information gain. How much information you have gained there can be lie in this particular segment. Moving further, gain ratio, again the important. The gain ratio is again information gain for S comma A divided by split information. Okay, just simple formula. IG is nothing but here information gain. The previous formula we have just studied. It's a bit mathematical thing. That's why I have already told you that you must be more focused and be patient to understand this decision tree, because looking at the decision tree, that basic concepts as you have seen in the multiple video, they can just simply explain you the decision tree, what is the decision tree, but they cannot explain these mathematics things. Okay, and these are the major important things with respect to your gate examination. You must have to remember this formula. Okay, that what is the information gain, what is the gain ratio, okay, what is a split info. Okay, so split info is have the simple formula with SV. You already know S, you already know log to SV over S, the same thing which we have discussed earlier. So just reduce the bias of information we have. Moving further, Gini index, one of the most important part. Here Gini index X has the formula is the simply 1 minus sum of all I belongs to 1 to C for Pi of square, where its range is from this probability of square we have. So it defines you that how much a particular factor M or a particular significance which a class have a particular thing. Okay, how many features are lies there in that particular classes of a segment M. So it is a range from 0 to the maximum 0.5. Cart uses binary split only. Keep in the mind. Okay, you just have to remember this particular formula again for your further note. So we need to be understand that these things are more important and these formulas are more important. Let's discuss more about the Gini index. Explore these things first. So this is the complete Gini index. Here you, I hope, able to understand that this cart, what the meaning of this cart is nothing but classification and regression tree. I hope multiple time in the previous also you have studied that what is a cart. It is nothing but classification and the regression tree. Here S in the Gini index, S is again the same the data set we have or the node we are using. C is the number of classes for at last we have that is sum of all I equals to the 1 of C. So C is nothing but the classes we have. Here after that we have the P of I for this. So Pi is nothing but the proportion of sample of classes I in S. Okay, just write it down. Pi is nothing but proportion of samples of classes I in the S. So what is the key intuition behind the Gini index? Okay, what is the key intuition behind the Gini index? You must have to be understand that how mixed the classes are in a particular node. Okay, how mixed classes are in a particular node. Just write it down. I am writing here. It gives you how mixed the classes are in the particular node. Okay, how mixed are the classes let me write how. I hope you have written this formula. So how mixed are the classes in the particular node. Okay, you must have to be understand this how mixed are the classes in a particular node we have. This is the measurements of Gini index. Okay, fourth index cart. I hope classification the regression tree we have and how much it is. Gini index is 0. That means your data set is pure. If it is not 0, that means it is not pure. Okay, so I have already written that it is 0. That means it is pure here. And if it is not 0, that means it is not pure in over segment. Simple things. Okay, for binary classification, maximum Gini index is just simply 0.5 when classes are perfectly balanced. That is 50-50 will we have. Okay, so this is a particular segment you need to be understand. So Gini index is used in cart, that is classification and regression tree. Okay, Gini again we can you just note it down. The first line is the fast to compute and after gives the more specified result. Okay, so I hope this thing is clear that we have right now studied about the four major things. Before comparing, I'm just go to back to understand, give you a big brief links. So this is the entropy. Entropy is this part. Randomness mainly used for the ID3. Then we have discussed about the information gain, also ID3 and C 4.5 there, where we have discussed about the information gain S comma A, which is nothing but entropy minus SV divided by S multiplied by H of SV. So that is the entropy of a particular subset of S, where feature A has the value V. Again, we have gone on the gain ratio. I know these things are a bit complex, but you need to be remember the formulas and understand the key basic concepts of these things, that what are the four major impurity measures. So four major impurity measures you have seen till now, and the third one is the gain ratio, and the fourth one is your Gini index, which can be mainly used in the cart. That is what I am also writing this classification and regression tree. Okay, what is the cart? If someone can ask you about the cart, that's nothing but classification, regression tree, a bit simple things. We are studying a very much in depth thing. Okay, बहुत ज़्यादा हम एडवांस चीज़ पढ़ रहे हैं, उसमें कार्ट आई थिंक ये तो बहुत बेसिक चीज़ है, आप लोग ऑलरेडी जानते होंगे. So now I have added this particular slide which helps you in understanding that in the decision tree is nothing but a supervised learning algo for classification and regression, what we have studied till now, in which most important is the Gini index and the entropy. Mostly asked questions are from the Gini index and the entropy. So in the previous year also Gini index is asked. So splitting criteria, entropy is nothing but the measure of impurity. Okay, Gini index where it is used, splitting, how much impurity of A splitting will be there. Then Gini index formula we have discussed, entropy formula we have discussed this. Okay, so Gini index and the entropy are the measure of impurity or disorder within a data set. Okay, what is a Gini index? It is the measure of impurity and the disorder in your particular data set. The goal of the decision tree is to minimize impurity. What's your goal? Is to minimize the impurity or maximize the information gain. Minimize the impurity. Impurity must be minimized and maximize the information gain. Okay, gain at each split leading to more accurate predictions we have. देखो ये तो एक जनरल चीज भी है, आप डे टू डे लाइफ में भी ये देखेंगे कि आपको इम्प्योरिटीज कम करनी है और आपकी इंफॉर्मेशन गेन को बढ़ाना है. तो ये तो सिंपल सी कहानी है. तो वेदर टेकिंग एनी डिसीजन, आपका इंफॉर्मेशन गेन बढ़ना चाहिए, इंप्योरिटीज कम होनी चाहिए. बस सिंपल सा कंसेप्ट जो हम इधर भी अप्लाई कर रहे हैं. उसके लिए हमने कुछ बेसिक पैरामीटर्स माने हैं, जैसे कि हमने इंफॉर्मेशन गेन लिया, हमने सर गिनी इंडेक्स लिया, हमने एंट्रोपी लिया. मोस्ट कॉमनली यूज आर द एंट्रोपी एंड द गिनी इंडेक्स, इन विच एंट्रोपी एंड द गिनी इंडेक्स आर नथिंग बट द मेजर कितना वेरिएशन, कितना डिसऑर्डर किसी डेटा सेट के अंदर प्रेजेंट है. ये हमें ये दो चीज निकाल के दे देगी. आई होप अभी तक आपको ये दोनों चीजें समझ में आ गई होगी. आई थिंक बोथ द थिंग्स आर क्लियर टिल नाउ. Now, splitting criteria, basic summary, that ID3 algo criteria is information gain. C4.5 is the criteria of gain ratio. CART mainly use Gini index or the MSE, and the regression tree or the variance reduction they can use. So this is a basic thing. You can write it down somewhere, important part. All these things are basic. Even if you remember the formula, you can easily solve the questions in the gate. Okay, keep in the mind, don't they can provide you each and everything. You just simply solve these questions by using this basic things. Now, continuous attributes, we have certain things we can study. That short values you have, try midpoints as a split candidate and choose the split minimizing impurity you have. This are known as a continuous attribute. Now, stopping criteria, what are the stopping criteria in this decision tree? That is, all samples become to the same class. Maximize depth reached, that time you can stop that particular decision tree. Minimum samples per node will be present, so no feature give the positive gain, then you can stop the splitting there. Pruning, what is an pruning? It's an important part. Okay, so pruning we can use to avoid the overfitting. That is pre-prune, that is early stopping will be there, that is limit depth, minimize sample per leaf we have, and the minimize impurity decrease. Okay, minimum impurity will decrease there. Post pruning, if you can do, there are the two pruning things. One is the pre-pruning and second one is the post pruning. Post pruning is to grow full tree, remove nodes that do not improve the validation accuracy, and it is a complete complex pruning for the card type of things. So this is the basically the pruning part we need to be understand in this. और भी अगर इसमें हम समझना चाहें कि प्रूनिंग का है क्या मैटर. आई होप प्रूनिंग, it is an English term you already know, that if any tree will become more complex, okay, more branches will be there, a lot of branches or unimpurities will be increases, or impurities will be increases in that particular tree. बहुत सारी चीजें उसमें increase होगी, impurities increase हो चुकी है, उसमें entropy increase हो चुकी है. तो इस तरीके के ट्री को हमें क्या करना पड़ेगा? कट करना पड़ेगा. Okay, already in the generally in your garden also you can cut the trees if the branches are not useful, okay, and they can restrict you for going outside and somewhere, so you can cut the roadside trees as well, na? So just like that, pruning in the decision tree algo is also the same concept. We can cut the branches. Okay, so they are the two major types of pruning, that is the pre-pruning and the post-pruning. I hope now you are able to understand that pruning, this is a simple English term. I hope आपको पता ही है pruning का क्या मतलब है. हम चीजें कट कर रहे हैं. Okay, pruning in the decision tree is just cutting the branches of the tree. When you can cut the branch from the pre-cutting or the post-cutting, so pre-cutting will be just simply early stopping, limit your depth, then minimum samples per leaf we can use, and you just minimize the impurity decrease. For the post pruning, you can see the grow your full tree, Post pruning, that is, now your tree is totally grown, so you can just grow your full tree. After that, remove nodes that do not validation or accuracy, okay, that do not improve the validation accuracy. That's why post pruning will be done. Pre pruning can be initial part. Post pruning, when the tree you have completely make and that is not a good tree or the impurities will be there, then you can go with the post pruning. Okay, I hope this basic concept are understand that pre pruning, sometimes the growth of your decision tree can be stopped before it get complex, so it is called as pre pruning. So post pruning, after the tree is fully grown, post pruning involves removing the branches or the nodes to improve the model's ability to generalize. Okay, so there are certain common techniques will be there, that is CCP will be there, reduce error pruning will be there, minimum impurity decrease will be there, leaf size minimization will be there, but that cannot be right now over main topic. Our main focus is on to discussion on the decision tree. Otherwise, this decision tree itself will become a 2.5 hour length complete video. Already we have exceeded a lot of time. We have already discussed a lot of things in this. So if we can discuss each and every concepts also of this, then it may, I think it will increase to 2.5 to 3 hours video. Okay, we can I can provide all these things, but in some lecture where we have a very huge segment, we have are taking a full length video. Right now, in short, for your gate point of view, you can easily, in the last time, you can easily clubs the things and easily recall the things which you have already studied. Then it will be beneficial. Although I have already discussed lot of things in this particular session, so that you can relate the things in a very good manner. Overfitting, underfitting, you already know. That's why I'm not wasting my time here. I think overfitting, if you found overfitting in your tree, that means very deep tree will be there, low bias will be there, high variance will be there. Sometimes in the theoretical part they can use. Underfitting, I hope you know the meaning of underfitting. That means shallow tree you required, high base bias will be there and low variance will be there. Keep in the mind, for the underfitting concept, high bias must be required and low variance must be required. Whereas in the overfitting, low bias be required and the high variance will be required. So decision tree with the other models comparison, most of the time it will be important. So aspects are non-linearity, if I can say. Decision tree is just simply with this non-linearity part. Linear models do not follow this. Interpretability, it's high interpretable, whereas it's a medium. Scalable, scaling needed, that is no scaling is required. It required linear models require the scaling part. Overfitting, high overfittings, whereas it is the low overfitting segment. So this is your complete overfitting and the underfitting part. I am just recalling this particular segment, what we have studied in this particular decision tree. Since video already becomes bigger, so we can discuss its problem in the next video, okay, in our part 2. So what is a decision tree? I hope you are able to understand. So just like here we have discussed a type of a car. So they are the two cars, SUVs, a minivan will be there, how much doors will be there, you can make the decision. So these are known as a decision tree. Whenever you are making any decision on a particular problem, that by using this particular tree, that particular algo is mainly a decision algos. So supervised learnings algo mainly used for the classification, the regression, root nodes, internal nodes and the leaf nodes may be used. So key terminology, splitting we have discussed, features, attributes, threshold, depth, impurity we have discussed. Then we have discussed in depth about what are the splitting, what are the different key terminologies in by using this particular diagram. After that, we have discussed about the types of the decision trees. That two major types of decision trees will be there. One is the classification tree, second one is the regression tree. In the classification tree, we have the three major algos. One is the ID3, C 4.5 and the CART algos will be there. In the which ID3 is the more commonly using with the information gain, then the C 4.5 we are using the gain ratio, and after that we are using the Gini index. Then we have the regression tree with the output, where is the output is a continuous, then we can say that it is a regression, and when the output is discrete, then it is a classification decision tree. Then impurity measures, most important part, entropy. You need to be understand this particular formula. After that, you need to be learn this ID3 formula, algos, that is information gain, which is mostly commonly used in the ID3. Then gain ratio, this particular formula is again the important part. Then Gini index, you can remember this particular formula. Then what are the major differences between Gini index and the entropy? You can easily found it down. Then just simple assembly of these with respect to the algo and the criteria we have discussed. Then the continuous attribute, what is the meaning of the continuous attribute, and what the things you have to keep in the mind. So while splitting the continuous attributes, okay. So type midpoints on the split candidates. Keep in the mind, whenever the continuous attributes are given, you can proceed with the midpoint theorems, just like find the midpoints of that, then split the things, okay. Just there are one more criteria, that is the stopping criteria. If your tree becomes too large, then stopping criteria will be helpful. Whenever you can stop a particular tree, this is the particular segments we have discussed. Then pruning, why you require the pruning, pre-pruning and the post-pruning we have discussed in this particular session. After that, at last, overfitting and the underfitting. In the next part of the decision tree, we can discuss about, we can take few examples, because it's already become the 40 minutes video, or the more than that, I think. So we can stop right now. So thank you so much. Have a nice day. I hope you like this particular video. So we will meet in the next session. Take care, students. Thank you.